By 2020, we must increase energy production from renewable sources by 20%, cut down greenhouse gas emissions by 20% and achieve a 20% improvement in energy efficiency. We must rethink the way we act and redesign the future. The target is clear. In this context, buildings are a crucial sector. They account for a large part of energy consumptions worldwide. Sustainable building and redeveloping could save us about 50% of energy, and at the same time, we would be contributing to our country's economic welfare and protecting the environment. The Effedil project aims to improve the thermal performance and water vapor permeability of bricks and develop environmentally friendly and innovative buildings materials through the study of the chemical and physical properties of hemp fiber.
The use of a natural material represents one of the pathways to achieve energy efficiency and environmental sustainability in buildings. In the DNA labs, the research was focused on hemp because it's considered to be a very interesting vegetal material also for the building industry.
Wherever it is grown, hemp can improve the quality of the soil and protect biodiversity because it is hardly susceptible to pest attacks. It can also be used as a viable and sustainable alternative to mineral insulating materials for the thermal insulation of buildings. On this basis, a short-chain model of circular economy is being developed in the Apulia region.
Collaborating with scientific research is essential for this emerging field, especially for companies like ours that produce raw material.
Within the Effedil project, thanks to their many years' experience in the field of energy efficiency and materials, the researchers of Enea Brindisi Research Center have developed a process that makes hemp fiber resistant to degradation resulting from temperature and humidity and does not involve the use of chemical pollutants. A brick wall filled with hemp was also realized, on which laboratory tests were carried out to evaluate its thermal properties.
In this study, we verified that hemp is a good thermal insulator and is able to attenuate the flow of heat from direct sunlight. With hemp, it's possible to improve thermal transmittance about over 20% and the thermal flux about over 30%.
Anti-mold and water-repellent treatments in aqueous solutions and with natural substances were also made. After immersion for 24 hours, the hemp fibers were dried at the temperature of 40 degrees centigrade for 96 hours. Chemical treatments on the fiber, observed with a scanning electron microscope, did not modify its morphology, while some differences, which are still being researched, were detected on its structure through the X-ray diffraction analysis. Then, tests to optimize the preparation of the mats were made. Tests with a cone calorimeter have shown that in case of fire, the treated hemp reduces the speed of propagation of the flame.
To evaluate the sensibility of the hemp fibers to the contamination by fungi, some hemp mats were artificially contaminated with two fungal microorganisms, Aspergillus niger and Cladosporium.
These organisms were chosen among those associated with the presence of mold indoors, a common cause of the deterioration of insulating materials. To evaluate the effects on the thermal, biological, chemical and mechanical characteristics of the mats of hemp fibers, they were subjected to accelerated weathering cycles in a climatic chamber. From a microbiological point of view, results were excellent.
Accelerated weathering tests performed in the Effedil project demonstrated that hemp fibers assure breathability by rapidly releasing the moisture absorbed, in particular when treatments to improve resistance to fungal contamination are previously made. High transpiration properties, of course, is considered favorable because it reduces the risk of retention of moisture and therefore the risk of interstitial condensation. At last, after accelerated weathering test, neither degradation of hemp fibers nor changes in thermal transmittance were observed.
Basically, the aging tests in the climatic chamber showed that color, weight and appearance of the material remained unchanged.
Another important aim for Enea is to create a network between university, institutions, local small and medium enterprises and farmers to increase the number of employers in our land and to improve the quality of life in a sustainable way.
The Daffodil project proved that the usage of this natural fiber in buildings has many beneficial effects. Best thermal insulation, increased transpiration, resistant to degradation and to bacteria, and in case of fire, the flame propagates at lower speed. Hemp is then the ideal insulating material for buildings in the Mediterranean areas. Saving energy is possible and sustainable. While you save energy, you save money and you save the environment.